Here's a video on lesson 60, going over the Pythagorean identity. Now, just to remember, a reminder of where we came from, question number 1 asked was the Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse. What happens if you apply the Pythagorean theorem to a right triangle inscribed in the unit circle? Well, the side lengths are cosine of theta, so look at this right here, cosine of theta, sine of theta, and 1. If I plug those in to the Pythagorean theorem, it gets me this, which is really important, which is what we call the Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. Now, I also gave you guys a little trick on how to tell which quadrant you're in, or what functions are positive in a given quadrant. The way we remember this is A, S, T, C. We say all students take calculus. And calculus, of course, being a high college or low college, or a high school or low college level math. So all students take calculus. Now, what the AS and TC actually mean is that in quadrant 1, all of the trig functions are positive. So that means sine, cosine, and tangent are all positive. In quadrant 2, sine is the only one that's positive. So unfortunately, cosine and tan are going to both be negative. In quadrant 3, tangent is positive, which means that cos and sine are both negative. And in quadrant 4, we have that cosine is positive, so sine and tangent are going to both be negative. You may use this to help you out a little later on. I'm going to go through a couple of examples. First one I'm going to start with is question 19. Question 19 says that sine theta is equal to negative 2.59. Negative 0.259, yeah. So the instructions here are to use the Pythagorean identity to find the other function's value. So we're looking for cosine in this case. And you're going to identify what two quadrants this angle theta could fall in. So let's start off with the Pythagorean identity. The Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Now what I'm going to do is I'm going to substitute in the negative 0.259 for sine. It's still plus cosine squared theta equals 1. We're going to solve this using our calculator, so I'm going to switch back and forth a little bit. Negative 0.259 squared. In parentheses, negative 0.259 squared. Enter. Everything is to 3 decimal places, so we cut it off at the 4th. So 0.067 is going to be the number we use. So 0.067 plus cosine squared theta is equal to 1. We are going to subtract 0.067 from both sides. Now I get that cosine squared of theta is equal to, this is going to be 0.9, 3. Let me check that. 1 minus 0.067. 1 minus 0.067. 0.933. Okay. Now that's cosine squared of theta. What I want is I want cosine of theta. So how do I get rid of a square? By square rooting. I'm going to square root both sides. Let's take that to my calculator as well. The square root of 0.933 and that gives me 0.9659. So we're going to round up 0.966. So cosine of theta is equal to 0.966. That is plus or minus 0.966. So cosine could be positive or it could be negative. We don't actually know. So that means that if I'm looking at a x and y axes, I'm looking at the 4 quadrants. This is 1, 2, 3, and 4. Since sine is negative, sine up here is my y value. So that means that y is negative. If y is negative, that means that I'm down. Cosine could be positive, which is positive x, or it could be negative x. But either way, I'm going to find myself in one of these 2 quadrants, which is 3 or 4. Okay, so that's how you did the first section. We do almost the same thing on the back, except we're going to be using the definition of the cofunctions in order to find those values as well. So we identify which quadrant, then we find the approximate value of secant, cosecant, tangent, and cotangent. We started off the same way. Cosine of theta is equal to 0.866, and sine of theta is positive. So in this case, they're telling me don't worry about the negative possibility for sine. I'll show you the full work here. I get that sine squared theta plus cosine squared theta is equal to 1. I'm going to substitute in for cosine theta. So sine squared theta plus cosine theta squared is equal to 1. Cosine of theta is 0.866. I'm going to go to my calculator to square that. 0.866 squared is 0.7499. Now here's the thing. I hope you can see my cursor. When I roll up this 9 gets crossed out, right? The 956 gets crossed out. This 9, because it's being crossed out and it's 5 or larger, it makes the 9 next to it increase. Well, that 9 would become a 10, which means that it becomes 0.75 because the 10 rolls into the next place. So 0.7499, do that off on the side, 0.7499. When I cross out the last one, this 9 rolls up. Well, that makes it a 10. 1 and 4 is 5, so I get 750. And we don't really need to write the last one, so we'll just keep the 0.75. So I get that sine squared of theta plus 0.75 is equal to 1. I'm going to subtract 0.75 from both sides. I get that sine squared theta is equal to 0.25. And now I have to square root both sides to cancel out the square. And I will get that sine of theta is equal to positive or negative. Let's see. The square root of 0.25 is 0.5. That's very convenient. So it's plus or minus 0.5. Well, I don't need to worry about the negative because they told me that sine is positive, so it's just regular 0.5. I remember sine is positive, they give me that disclaimer right here. So we're using the positive value of sine. So now we have sine and cosine. Let's do a little cleanup here. Sine of theta is equal to 0.5. Cos of theta is equal to 0.866. They want me to find these four. They want me to find secant, cosecant, tangent, and cotangent. All, of course, of theta. Same angle. All I need to know is the definition of these. Secant is equal to 1 over cosine. Cosecant is equal to 1 over sine. Tangent is equal to cos, no it's not, it's equal to sine over cos. And cotangent is equal to cos over sine. All I need to do is plug in. I'll color code these because it'll be a little more fun this way. Let's make sine red. Let's make cosine green. So when I plug in, all I'm doing is taking the number exactly as it is, and I'm plugging it in, and I'm evaluating the calculator. So secant is going to be equal to 1 over 0.866. Cosecant is going to be 1 over 0.5. Tangent is going to be equal to 0.5 over 0.866. And lastly, cotangent is going to be equal to 0.866 over 0.5. I'll evaluate those in my calculator. 2 at a time. 1 divided by 0.866. Enter. So that's 1.155. That's secant. Now 1 divided by 0.5, that's 2. Let's check the next one. 0.5 divided by 0.866. It's going to be 0.577. And lastly, cotangent is going to be the flip of that, 0.866 divided by 0.5, 1.732. And there you have it. That's secant, cosecant, tangent, and cotangent, all to 3 decimal places. The last thing that I need to do is I need to identify which quadrant this angle would be in. Now, let's think. You can just use down here. Sine of theta is positive. Cosine of theta is also positive. Which quadrant, all sine only, cos only, or tan only, which one of these would allow both of these to be positive? The all option. You can also think of it like this. Cosine is my x value. So positive cosine goes in this direction. Positive x. And a positive sine is going to be a positive y. So it's going to be in quadrant 1. And that's everything that they asked. So I hope that that was helpful. Enjoy the rest of your homework. See you in class.